Alright, welcome to the lunchtime video. Lots of very uncertain times we're living in today, but I'm going to do my part to keep things moving along as normal as possible. So I'm going to be continuing to work on the JNCIE-SP. So let's dive into that. So I did switch to a different recording software. Hopefully the audio quality is a little bit better now. Let's see here. So let me check the prop. Okay, yep. So I'm definitely reporting with my webcam now, and I've got the volume adjusted, so the loudest noise I make won't be clipping the mic or up too loud anymore. It's going to be about maybe a little bit into the yellow, but mostly just the top of the green. And then the softest noise I make is going to be right about here, so hopefully that's better. I know the audio has been really bad, but you can see I can adjust the levels a lot more fine than I ever used to be able to, so I think that's going to help a lot. Okay, so where I left off in the last video, I was learning about shared risk groups in MPLS, traffic engineering. So a shared risk link group. So let's keep going on that. I'm going to be going into the second video for that. And I actually don't remember what was covered in the first because it was a few days ago by now, because things are just so uncertain in these times that I don't even know if I'm able to take the test anymore. So it's unfortunately let me see here. So okay, like that. Shoot, I wish I could change the because right now I'm trying to change the size of the image of me on here, but I wish I could just make it like really like wide so I look like really goofy. But anyways, we've got the second video we're going to work on, so let's start off the video by just going through some of those resources that I had listed. Okay, and another thing I would like to do is just go to my YouTube channel. Oops. Yep, and then just take a look at the last one I uploaded, the last few minutes, see where I left off. Now I know if I choose ISIS though, I will need to change the timers so that it can drop. Oops. Yeah, so where I left off, I think I was just gathering resources. Aha, and now I remember I wanted to go through these examples. Router. Actually, no, never mind. I've got 8 routers because I've got 2 just sitting out in the corner doing. Yeah, so I was just going to go through this example here. So let's do that. And I believe I read the overview already. I guess it won't hurt to read it again. So in MPLS traffic engineering, a shared risk link group, SRLG, is a set of links sharing a common resource, which affects all links in the set if the common resource fails. These links share the same risk of failure and are therefore considered to belong to the same SRLG. For example, links sharing a common fiber are said to be in the same SRLG because a fault with the fiber might cause all links in the group to fail. And SRLG is represented by a 32-bit number unique within an IGP, OSPF-v2, and ISIS domain. A link might belong to multiple SRLGs. The SRLG of a path in a label switch path, LSP, is the set of SRLGs for all the links in the path. When computing the secondary path for an LSP, it is preferable to find a path such that the secondary and primary paths do not have any links in common in case the SRLGs for the primary and secondary paths are disjoint. This ensures that a single point of failure on a particular link does not bring down both the primary and secondary paths in the LSP. When the SLRG is configured, the device uses the constrained shortest path first algorithm and tries to keep the links used for the primary and secondary paths mutually exclusive. If the primary path goes down, the JNCIE-SP algorithm computes the secondary path by trying to avoid links that share any SRLG with the primary path. In addition, when computing the path for a bypass LSP, JNCIE-SP tries to avoid links that share any SRLG with the protected links. When the SRLG is not configured, JNCIE-SP only takes into account the costs of the links when computing the secondary path. Any change in link SRLG information triggers the IGP to send LSP updates for the new link SRLG information. JNCIE-SP computes the paths during the next round of re-optimization. Okay, so I do remember reading that before. So let's move on. I'll read the overview and then we'll go to the configuration. If anyone was curious why I said, oh, that's weird, it's because as I was moving my mouse around and I'm looking out the window and there was one of those bugs that are the size of a hummingbird out there. I still don't know what those are. Probably cicadas, but as I was moving my mouse, it was moving. It just coincidentally happened to be moving the same way as I was moving my mouse, so it looked as if I was moving the bug around. But let's continue reading. Overview: Junos OS release 11.4 and later support SRLG configuration in an IGP, OSPF v2 and ISIS domain. In this example, you configure SRLG and associate it with the MPLS interface on a device. The device uses the SRLG cost parameter for the constrained shortest path first JNCIE-SP algorithm and tries to keep the links used for the primary and secondary paths mutually exclusive by avoiding links that share any SRLG with the primary path. To configure the SRLG, you first define the SRLG parameters at the Edit Routing Options SRLG name hierarchy level, and then associate the SRLG with an MPLS interface at the Edit MPLS interface name hierarchy level. The SRLG-name statement has the following options. SRLG-cost, include a cost for the SRLG ranging from 1 through 16 bits on. The cost of the SRLG determines the level of impact this SRLG has on the JNCIE-SP algorithm for path computations. The higher the cost, the less likely it is for the secondary path to share the same SRLG as the primary path. By default, the SRLG cost is 1. I'm actually kind of questioning myself if that is 16 bits on. It might be 12 bits on. I'm going to check that. Oh, no, it is 16. Okay, that's what I get for second guessing myself. I just wasted a bunch of time. SRLG-value include a group ID for the SRLG ranging from 1 through, okay, now this one I don't know. I think it's 32 bits on, but this one actually won't be a waste of time to check because I legitimately don't know. Yep, okay, it's 32 bits on, but I wasn't as sure of that as I was of the other one. And you're setting a cost, so your options are 1 through that. In this example, PE1 is the ingress router and PE2 is the egress router. P1, P2, and P3 and P5 are transit routers. OSPF is configured on all the routers as the Interior Gateway Protocol, IGP. SRLG is configured on all 7 routers. The primary path includes SRLG, SRLG-A for the standby secondary path. The link P2 to PE2 belongs to SRLG-A. The effective link metric with the added SRLG-cost of 10 becomes 11. Therefore, the computed secondary path is PE1, P3, P4, P5 to PE2 with a CSPF link metric of 4. So basically the point of SRLGs is to make sure that your LSPs do not take the same path, because otherwise they'll all just go down. If there's a link failure, you want them to have different paths so that one failure does not bring down all of your LSPs. It just brings down the one LSP going over that path. Okay, so let's do the hands-on. All right, and I'm going to put this here on my first screen so I can see at all times what will be showing up in the video. Okay, so now we're going to be doing this, and we're going to be rearranging this lab quite a bit. I think we'll also need a 7th router for this. Yep, so I'll add that. All right, perfect. And then I will connect the control plane to the forwarding plane. All right, and then I will get rid of all the links on here. Oops, and before I do that, I will power this up so that it's up by the time I'm ready to go. Oops. I can turn all the labels off for now, so it's easier to click. Oh man, it's so noisy outside. I think I'm gonna go with these. It's just a truck passing by, so it won't persist. The noise won't persist, but sometimes these are just a really welcome relief, even though they start to kind of pinch a bit too much after a while. You should probably invest in some good noise canceling headphones, but I mean that's just a lot of money. This was like 35 bucks, and really I only need temporary relief most of the time. All right, so let's go back to the, okay, so we're gonna have special names. So we can just arrange this in any way and then change the host names. Alright, so now let's change the host names. We won't need to change the name of the forwarding plane, just the control plane. Oops, now it looks like I accidentally had it double selected. This is a common problem. Looks like it didn't cause any issues this time, but I'm going to be more careful to just single select. Okay, so now I've got to unselect. Okay, and then I've got to select. Perfect. Alright, now unselect and select. Unselect, select. Alright, unselect and select. Perfect, so we've got everything good to go now as far as the naming is concerned and the topological arrangement. So now we're going to need to figure out how the cabling works. So, okay, well, let's see here. So, and there's no, there's unfortunately no descriptions. So it's going to be a lot more difficult than if there were descriptions. But I can make it easier on myself by using this. Okay, I don't think I need any of these anymore. Alright, so here's going to be the port configuration for PE1. So I'm going to just isolate this and then add some descriptions, and it should be a lot easier to understand how the cabling needs to be set up. Oops, so there's no PE6, there's going to be PE2. Okay, so, yep, we've got 4 P routers, and then we've got, actually we've got 5 P routers, and then we've got 2 PE routers for a total of 7 routers. So let's figure out which are connected to which. So to do that, we'll just mark the, here we go. So now we've got 2 matches. So we know that these are connected to each other. So let's add the description. Okay, and it looks like we can do the same port syntax. That's fine. We just won't be using GE000. Nothing wrong with that though. If they had a different syntax where it was, for instance, 1/0/0, we wouldn't be able to use that. But let's keep using the syntax they were using to save ourselves some work. Okay, so it's time for the next one. Oops, I forgot to change the port. Perfect. So I'll need to sometimes change both the port and the description. Other times I'll just need to change the description, and then other times I'll just need to change the port. So in this case, and there will be some times where I don't need to change the description or the port. That is the case right now with PE2. So we've got one more interface to add a description on for PE1. Okay, and this is going to go to P3, as is pretty predictable here. And I like the naming they're using for the ports as well, because port 3 goes to P3, makes it really nice and easy. Okay, so everything is good to go on P1. Let's go down, PE1. Let's go down to P1. So we've just got one more interface. Okay, so this goes to PE2. Okay, this is also going to PE2. Just like for P1, we had a connection to PE1 and PE2. Same thing for P2. And it is a bit difficult to, I think, sometimes understand the speech of P1 versus PE1. Sometimes that E gets lost and it's not quite dictated clearly enough. So you know what? I might just say provider 1, provider edge 1 might be more clear. So okay, so yeah, I think I'll do that. So provider edge 2 router is gonna connect to the provider 2 router. All right, so moving on, we've got provider 3 router now is missing a description on its second interface. Okay, but this one's going to provider 4. Okay, and now this is going to provider 3. Okay, so now it's time for provider 4. Okay, so now every router has descriptions on all of its ports. So I think what I'm going to do now is just configure them all and then worry about cabling them up after the configuration has already been applied. Okay, so let's start with provider 2. Oh, some of these don't have that's interesting. It looks like the provider 2 and provider edge 1 and provider edge 2 maybe because there's I see there isn't enough space to list it. Okay, so this is, oops, so it looks like it still says that it's, oh, right, because, so before I paste that in, I'm going to blank out these configurations. Okay, so the candidate configuration is now blank, the running configuration is still this, but we're going to need to add back the things that were made blank that we do want to have a value for. So this is going to be hostname P2 now. Okay, and then we'll also need these. So we're just going to have 4 lines of configuration now, stripped down to its core. So lots of big changes. But if I just do a show pipe display set to look at the candidate configuration, we can see we've now just got those 4 lines. If I do a run show configuration pipe display set, I look at the running configuration, the active configuration. You can see it's all still there because it's in the active configuration, but it's no longer in the candidate configuration. So if I do commit, I will move what's in the candidate configuration to the active configuration, and what is currently in the active configuration will be archived, and it can be looked at with show system rollback compare. All right, so let's do that for all of the routers. Next is PE1. Oops, and it looks like PE1 is the new router, so it's still coming up. It's going to take about 6 minutes for it to do that. So we'll move on to P1. Perfect, so we've got it at P1 now. Everything is all set for applying this. Hopefully I can get all this done before the end of the lunchtime video. If I don't get to cabling it up, that will be totally fine. But I definitely want to get that configuration applied, since I don't want to have to remake that. Alright, so time for PE2. Alright, so P3 is next. And hopefully PE1, provider edge 1, is on its way up. And we will need to go to provider edge 1 and add some base configuration to that. Hopefully a license won't be necessary. Now, one thing that I dealt with between videos is my trial license for ESXi has expired. Now, I did find a free license that you can use, but unfortunately it only allows for 8 virtual CPU cores. So right now I am running my lab at half the capacity of CPU cores as I was running it before, but I don't really see any performance issues. It could be that this boot up now takes 12 minutes instead of 8 minutes, instead of 6 minutes, which would not be ideal, but as long as I can still use it, it's not going to be a huge deal. Alright, so that's P3. Let's move on to provider 4. Once I can verify that the hostname did change on this. Alright. Alright, so we've got one final provider router to go. That is P5. After that, we're going to need to check in on provider edge 1 again. As I mentioned, I am using half the number of virtual CPU cores as I was before, so that boot up might now take twice as long. At least. But it used to only take 6 minutes before, so 12 minutes isn't gonna be too much of a game changer. Okay, so now it's time to go check on provider edge 1, and hopefully that will be ready now. Alright, so it's still coming up. That's fine, we can skip it and add the configuration to the other routers and then come back to it. I've still got a good 20 minutes. I do have a meeting at 1 today, but I think I'll only need 20 minutes. Is it Tuesday or Wednesday? I keep thinking it's one day later than it is for some reason. I'm not sure what I did on Sunday to make me think that, but it must have been something. Okay, so on all of them, I'll just do a quick verification first, make sure I did everything right. Often I will forget to delete the candidate configuration before making my changes, but looks like I did a good job this time around. All right. Right, moving on to provider 1. And now provider edge 2, which is going to have an extra interface on it. Perfect. So hopefully this is up by now. I think it's been longer than 6 minutes, but with that change to the virtual CPUs, it could take quite a bit longer than what it used to take. Okay, but I can start wiring things up now. Even though this is not up, I can make the connections. So, yep, let's start with the first connection, which is going to be 1, 2, 1. Okay, that's going to be 2, 2, E, 2, 1. Alright, it's going to be 3, 2, P3, 1. Alright. Okay, so this is these are all the connections that need to be made. Hopefully this is up by now. Alright, so this is typically the last step before it goes up. Yep, it's taking a lot longer than it ever used to, but that's no surprise given the new license I'm using now. I do have plenty of time. At the very least I have 10 minutes. So I think I'll just sit and wait for this. I guess I'll check the lab, see if there's anything I can read or that's going to be interesting. Let's go through this step by step and see if there's a more verbose explanation of any of the steps. Okay, so I don't see anything like that. Once that provider edge router 1 is up, we won't be able to go onto the verification steps yet because we're going to need to add the other interface that is not just interfaces config. So one thing we can do is verify that right now. So we've got lots of really familiar config. One thing to take a note of is that we're going to be using RSVP, which means we'll have to use manual label switch path statements. And then we're going to, of course, have our regular MPLS configuration and OSPF. Of course, we're going to need an IGP so they can make the CSPF calculations. You notice we didn't have to turn that off. That's because we've got only a single area. If I come down here, you'll see that they're all using area 0. If they were in multi-area, then we would have to turn off constrained shortest path first because it would not be able to make a single calculation for the entire end-to-end LSP. Similarly, if we had ISIS, that would be true as well if we just had the default implementation, because we would have level 1 and level 2 connections. You would have to disable all of your level 2 connections and only have a straight level 1 connection end-to-end for the LSP in order to run CSPF. Alright, so let's put this side by side. Oh, it looks like it's still going. Yep, so this unblocking device is one of the last steps. This loading the module. So we're very near at the end here. Just not quite there yet. Yeah, I'm using a different recording software. I used to just use a Zoom conference and then save it, and I'd have to wait for it to save to my hard disk, then I'd have to wait for it to upload. Now I'm using OBS, which is a little bit better because I can adjust my microphone input levels a lot easier. I can also adjust my size of my icon a lot easier. So I like it a lot better. And not only that, the best feature of it is once I hit stop recording, it's already going to be on my hard disk. It just saves it as I go. And then all I've got to wait for is the upload to YouTube. So in the last 5 minutes of my lunch hour, I can have it completely ready to go, and I don't need to just have my laptop kind of sit in stasis until I get a chance to upload it. I can upload it, have everything all set, ready to go, unplug the laptop, close it, and everything is taken care of. While this is waiting, I'm going to do a Google search for ESXi Unlimited license. Yeah, so let's look at some of the limitations between free and paid. So this is what I have right now. I have a free version, so you can see I'm maxed out at 8V CPUs. Before I had up to 256. Maxed out at VRAM. But it seems to be working pretty good. It's just this is taking much longer than it ever used to take to come up, which is definitely a little bit of a problem. But since I have that cron job, it's just going to be automatically doing this. All I might need to do is just adjust that cron job to trigger half an hour beforehand, 20 minutes beforehand. Right now it's only allowing it for 15 minutes. So if I ever get in a situation in the lunchtime video or the after work video where all my routers are still loading up, all I'll need to do is adjust that cron job to allow more time for that. Okay, but we're at the CLI now, so let's add those base configuration statements and then configure up the interfaces, and then we'll be ready to move on with the rest of the config. Okay, so I'll open up another one so I can see what those base configuration statements are meant to be. So this is definitely going to be one. As well as these two. Oops, so it looks like the server side unexpectedly closed the connection. So I think I might have entered an extra exit statement or something. Hopefully that won't happen again. Okay, so this is new. I haven't seen it behave this way before. Let's check some of the statistics. So here's the server summary. Oops, it says that it's showing it, but I don't see it. Okay, so let's just close everything and then see if it's pop up. Oh, I actually do see it. It looks like it opens on my other screen for some reason. And unfortunately, it looks like I'm not able to drag it over. The other piece of really bad news right now is that my CPU is at 96%. So that is a lot of percent for my CPU to be at. Let's take a look at some of the statistics provided by the ESXi GUI. Yeah, and I can take a screenshot of what I'm looking at and then post it in the so it shows up in the actual video. Unfortunately, there seems to be some kind of bug with the GNS3 GUI where it won't show up in a more convenient area of my screen. But you can see this is definitely not going to be a suitable number. But it only says it's at 71%. So it looks like that's good news. I do have the this CPU number here is the percentage of the GNS3 VM that it's using, not of the total VM. So the fans aren't quite going crazy yet because I've got so here it's going to be at like 90%. Yeah. So consumed host CPU, it's at it's at 100% now. Over 100%. Yeah, so that's going to be a problem. I really wish I could get this up to 16 again. Throttling down my CPU, available CPU by half, believe it or not, is having pretty big performance issues. And I believe it. I think it's quite believable. Yeah, so the virtual CPUs available to a virtual machine depend on the number of licensed CPUs on the host and the number of CPUs supported by the guest OS. To use the VMware multi-core virtual CPUs feature, you must be in compliance with the requirements of the guest operating system EULA. Yeah, so I'm not sure what's going on here. Well, I am sure what's going on here. I guess I'm not sure what's going on with this here, because I thought it would be... okay, so I'm in there now. I guess it's just going really slow. Okay, but I finally got it going. So I just got one last piece, and then I'll come back to this. Hopefully in the after work video from 5 to 6, I had planned to do these videos. Perfect, so everything is good to go. So that's going to be the end of this video. In the after work video from 5 to 6, I'll be adding the rest of this configuration. It looks like having half of the CPU power I used to have really isn't going to be a huge deal. So thanks for watching, and I'll see you in the after work video.